So Curtis, hi, by the way.
Hello.
Uh, One of the reasons why storage is exciting again is because of what's happened, frankly, with AI. It's made everybody step up their game a little bit.
Yes.
So I know everyone in this room is already familiar with, obviously, the compute challenges from AI and the low latency demands from AI, but let's just talk from a systems and storage software engineering perspective. What have you had to completely rethink? I mean, you've been doing this for some time, right?
Right.
What engineering differences are there, and what do you do?
Right. So the workload that HPC provided to storage for the last couple of decades has been pretty consistent. It is growing in bandwidth, but not particularly in any other characteristic. So AI is the first case where we're really seeing latency become an issue for us. It's becoming an issue just in general, but at a much slower rate than other things that are changing, right? So now AI shows up, and all of a sudden latency is a big deal. But as we heard earlier from Brian, that there's this other change that has snuck up on us as well, which is just the total quantity of metadata, the total number of files. The latency, for example, how long does it take to open a file, read some about it out of that file, and close it? So those things are now forcing change in the storage subsystems that are used in HPC environments, including Panasas.
Right. So you've had to do some re-architecting, right, to deal with mixed file types, mixed file sizes.
Right.
Talk to me about some of those key changes and how long did these things take, and what was the complexity and learning curve of doing this? Ultimately,
Right.
I'm guessing you were left with a much better end product that can do both AI and HPC and even large-scale enterprise stuff. But that must have taken some rip and replace.
Yes. So there's a short-term, well, I don't want to call it short-term, it's actually quite a bit of effort, but there's a thing that we're releasing now, which is the ActiveStore Ultra project. Our architecture has three major components. We've taken one component there and completely re-implemented that component. That helps us with some of the latency challenges. It helps us with bandwidth. It is finishing getting us off of our proprietary hardware onto the commodity hardware. We've been talking about portability rather than software defined, in the sense that we can move the software, but we don't leave it to the customer to do the integration with all the risks that are that. So now our cycle time is down to like 6 months to go from wherever we are to the next generation of hardware. So that's a huge advantage for us. So that's sort of a short-term thing. We integrate hard drives, SATA flash, NVMe flash, and NVDIMM sticks all into a platform that's going to be really good at a wide range of workloads. But we're still left with this latency challenge. As we've heard earlier, you build architectures for bandwidth, and they're really good at bandwidth, but generalizing those to also do latency is Herculean. That's just a really big task. So now that we've finished with that, the Ultra project and generalizing that, getting up to modern standards on hardware, software, and architecture, we have started a new project which is going to try to address the latency challenges. We're calling this the Ludicrous Mode project for
Ludicrous. Okay, Ludicrous project. Okay.
Ludicrous Mode, yes, for extreme acceleration. So this is just the internal project name, and it's very cool for us. And the product name may be different when it comes out, but we're trying now to say, okay, that all's done. What are we going to do for the upcoming challenges of latency of IOs, keeping the GPUs busy, enormous quantities of metadata? How are we going to start addressing that challenge?
Are the things that you're architecting around coming from where you think the market is going to go, or are these things you're seeing right now? Where are the drivers coming from? Are they coming from the really big labs? Are they coming from smaller research centers that are I wouldn't call Brian's lab small, but his section of what he's working on, they have a relatively small amount of compute that's available to them for some of these things. So where's the driver for this?
So we tend to look at the overall HPC market as a pyramid, and up at in the middle there is sort of commercial-ish HPC, and below is real enterprise, right? Up the top is, no disrespect, but that's sort of the lunatic fringe, the people who are really pushing the edge, right? And there's
We'll do lunatics, I'm just saying.
there's clearly a tremendous need for that to happen, right? But the requirements there are, as we heard earlier from the gentleman from IBM, right, that's an entirely different business model of how you service that market, right? So we tend to play in the next tier down. And so what we've We heard from Gary Ryder for like 6, 8 years now, oh, metadata is the big thing. It is, but it was only present at that upper tier, right? And so now we're seeing these requirements come down, right? And AI is one of those big forcing functions that's driving it, but the metadata challenges as well.
Coupled with that, there's increasing complexity in the number of layers and types of storage.
Yes.
Talk to us about this for a minute. We'll break down, I think everyone in this room knows what those storage challenges are and layers are, but
Right.
how are people thinking about managing all of that? Is that happening in HPC at all? Are people really adding to the ranks of storage layers that they have, or?
There's two sort of major things going on. There's a lot more. It used to be that there was hard drives and tape. Obviously tape wasn't really something you could access. You had to restore it and then use it, right? Nowadays there are these 4 layers: the hard drives, SATA flash, NVMe, and NVDIMMs, right? And so there's a whole set of challenges there. But at least we have taken the role of saying that all should be managed inside the storage product, so that the application software and the administrators don't need to worry about that. The NVMe over Fabric, however, is something we haven't done yet to date. That's part of the Ludicrous project. We'll start exploring, okay, how are we going to manage that? But you've seen burst buffers and those kinds of technologies, but they haven't been integrated into storage. They've been, relatively speaking, more difficult to manage because they're separate. We've also seen a combination of what I refer to as less sophistication in the application software stack, where the application writer is more concerned with their algorithms, their outcome. Genomics is a great example. These are not computer science people, they're geneticists, right? And so they don't care whether an I/O pattern is efficient or not. They create literally 1 million small files and say, that's good, right? So there's that, and then there's the explosion of metadata. And so those are challenges that are coming down to the storage subsystem. If we want to make it easy for the software writers and everyone above, then we have to find ways to that's our opportunity, is to help solve those problems and make it easy on the layers above us.
Do you see a lot of NVMe happening in HPC at that top tier of the pyramid over the next few years?
I think that NVMe over Fabric is going to...
Fabric, I meant to say, yeah.
Yeah, no, that the over Fabric is an important characteristic because I've talked about putting NVMe into compute nodes a couple of years ago, and then finally realized, silly boy, that the disaggregation is important. So the over Fabric is important. Burst buffers, and that people have toyed with that. I shouldn't say toyed, but they've experimented with that kind of technology and had valuable products, right? I think that NVMe over Fabric is going to come in across all the layers at once, right? It's not going to start at the top and trickle down, right? The burst buffers started at the top, but that was because they had a specific requirement, and it was something that had to be addressed at the top of the pyramid. NVMe over Fabric is already a commodity hardware product. The challenge is that it's a block storage device, not really different from a fiber channel disk array from 20 years ago. And so how do you manage that? Well, that either takes a disjoint product like a burst buffer management software, or a software vendor, a storage vendor, to step up and say, okay, we're going to manage it for you. So that's my guess, is that it's actually going to come in across the board. I think that the enterprise customers way down at the bottom of the HPC stack are going to adopt them at the same time as the top does.
That's interesting.
Right.
I don't disagree with that projection either. I do want to move out to questions, if that's okay, while we have an extra 2 minutes. Talking storage here, does anyone have any questions?
Can you speak to persistent memory sitting close to CPU now that that's coming up in your hierarchy? Maybe there is that.
Sure. We use NVDIMM in the current suite of products that we have, and so we're starting to get familiar with what can you use them for, right? The single biggest challenge with storage class memories inside the box is that it's not disaggregated, right? That if that box goes down for whatever reason, software, hardware, whatever, then nobody else in your cluster has access to that information. Was the light bulb lit on why NVMe over Fabric is better than NVMe in the box, right? Now, there's too much performance advantage there to not try to find a way to make use of storage class memory in the box, right? But you're either then going to have to synchronously replicate it somewhere, or you're going to have to relax the acid properties of your storage, reduce the durability a little bit, and say, you know, it's okay for that data to have been lost, right? And I might have to restart a job or a piece of a job if a failure happens, right? So that's the challenge, and I'm not sure that the storage software market has a good understanding yet of how to manage that, right? That's one of the things that the Ludicrous project we're trying to do is say, okay, take this 5-year view and what all are we going to have to manage? How do we manage that? How do we take the load of managing that off of the customer? So.
Well, we'll definitely be keeping an eye on the Ludicrous project. We're always watching for what's next in storage at Next Platform. And hey, Curtis, thank you so much.
Thank you.
Thank you, everyone.